All right, so what we're going to do in this particular segment in this lesson is basically the what most people would consider to be solving limits in a calculus class. Everything else that we've done up till now has just been sort of like getting the idea of limits or understanding that two-sided limits are basically one side and the other side together, okay? But what we're about to do, solving analytical limits, is what most people would consider to be the heart of solving limits. So this is probably going to be the longest segment in today's lessons, okay? All right, so what I'm going to show you how to do is, now you don't have to write this part down. This is just an example of what it looks like, okay? What we're basically going to do in this lesson is I'm going to show you how to find the limit of a function as x approaches k. Okay, so the limit of f of x as x approaches k, notice it's a two-sided limit, okay, where k is a constant value. I mean, this is exactly what we've been doing up until now, okay? So it's x approaches some number, okay? I'm just clarifying. I'm creating a generic form of it by putting a k in, but that k can be any number, okay? So k is a constant value, and f of x is an analytical expression. Has to be defined analytically, okay? And so here's an example of what we have here. So we have the limit as x approaches negative 23 of the function x plus 5 over the square root of x plus 100. We're not actually going to solve this, although you could. It's very easy to do. But I want to point out here that k in this case is negative 23, and f of x is x plus 5 over the square root of x plus 100. Okay? And so what I'm going to do is I'm going to give you a procedure, step-by-step procedure on how to approach any limit problem that has this quality, where there is a number here and there is a function there. So let's go ahead and get to that procedure. All right, so this procedure basically has 4 steps, but the steps can be sort of large. Like this first step is actually kind of large. It has 3 parts or 3 results that could occur from doing the first step. So the very first thing you do, anytime you solve a limit, the first thing you're going to do, step 1, is always substitute the value k in for the x variable in f of x and evaluate. I actually taught you to do this at the end of day 1. In the very last segment, I showed you how you just sort of take the number and you put it in for x and evaluate and get a number, okay? And so one possibility is when you plug the k into the function, if you get a numerical value as the answer, then that is the answer. And here's an example, okay? We have the limit of x plus 3 over x plus 1 as x is approaching 2. So the first thing you're going to do every single time is take that number and put it in for x. So we're going to put the 2 in. We're going to do 2 plus 3, that's 5, okay? And then we're going to plug the 2 in here. 2 plus 1, that's 3. And therefore, the answer is 5/3. And we're done. There's nothing else to do. 5 over 3 is the answer. We move on to the next question. Okay? But a lot of times you don't get a numerical answer. So we're going to go on to what you're going to do if you don't get a numerical answer. All right. The second possibility is that you're going to get a fraction. And that fraction winds up being a 0 in the denominator and not a 0 in the numerator, okay? Now, I refer to that as not 0 over 0, okay? So if you get a fraction, for example, if you get like negative 10 over 0, or 5 over 0, or 1 over 0, any number that's not 0 over 0, that's our second circumstance here. That's the situation of B, okay? If that happens, okay, if you get not 0 over 0, then there's no limit, okay? It's basically a vertical asymptote. That's pretty much what's happened here. You've encountered a vertical asymptote, and with a vertical asymptote, the answer is either no limit. Why? Because it's either infinity or it's either infinity or negative infinity or neither one of those things. But there is absolutely no limit. And so here's what you're going to put for the answer. Anytime you get not 0 over 0, you're going to put no limit, or you're going to put DNE for does not exist, or you're going to put non-existent. They all mean the same thing. So if you look right here, it says, what is the limit of x over x plus 8 as x approaches negative 8? So we're going to put a negative 8. We're going to do our substitute. We're going to do our substitution. It's always the first thing you do. we're going to put a negative 8 in here, and we're going to put a negative 8 in here. If we put negative 8 in for x in the numerator, we get a negative 8 on top. Over, if we put in negative 8 in the bottom, we get negative 8 plus 8, that's 0, right? So we have negative 8 over 0. Now, let me be very clear about something. You are not going to put negative 8 over 0 over here, because that is not an answer. You can't have each equals the answer negative 8 over 0. Negative 8 over 0 is not an answer. That's why I'm doing it all the way over here on the side, okay? The answer is, because I've come up with not 0 over 0, the answer is either no limit. As the answer, I'm going to write no limit, or I could write DNE for does not exist or non-existent, okay? That is the second situation, okay? And now what we're going to do is we're going to look at the third situation, which is, it's not that it's the most common situation, it's that it's the most common situation in a calculus class. It's why we study limits. This first situation, the second situation, they're kind of important, but the third situation really is the reason that we study limits in a calculus class. Okay, the third situation is if you get 0 over 0, okay? Now, I don't have enough room here, but I put C here, so just put this one underneath A and B in your notes, okay? If you get 0 over 0 after substituting K in for X in the function, then you're just going to go on to step 2. This is where everything gets fun. This is why we have step 2, step 3, and step 4 in this procedure. See, if you wind up with option A where you get an answer, you're done. You don't need step 2, 3, and 4. If you get option B where you get not 0 over 0, there's no limit. You're done. You don't move on to steps 2, 3, and 4. But in the third situation, if you wind up getting 0 over 0 as your output, then you're going to go on to step 2. Now, let me also say this. Let me remind you. The answer is not 0 over 0. And it's also definitely not 1. Because a lot of people will see 0 over 0 and they'll say, well, any number divided by itself is equal to 1. Yes, but 0 doesn't count as like an actual value. I mean, it's a value. It's the absence of value. Okay? And therefore, 0 over 0 is an indeterminate form. And therefore, we have to do more to come up with the solution. Remember what we said when we reviewed wholes? 0 over 0 implies that there is, or indicates that there is a hole there in the function. And remember, when there is a hole in the function, okay, we just saw with the graphical limits, the limit can still exist. We can still have an output value even if there's a hole there, okay? And so let's look at this situation. We've got the limit as x approaches 7 of x squared minus 49 over x minus 7. Well, if we plug the 7 in here, 7 squared, right? 7 squared minus 49. Well, 7 squared is 49. 49 minus 49 is 0. Okay? Now let's put it in the bottom. 7 minus 7. Well, 7 minus 7 is also 0. So we got 0 over 0. That's not an answer. Don't put 0 over 0 over here. Okay? What we now have to do is we have to do step 2 and step 3 and step 4, and then after we're done with all that, then we can put an answer here, okay? All right, so what we're going to do now is we're going to move on to step 2. All right, so now you're going to move on to step 2. So here's step 2. Look at f of x, you know, your function that you plugged k into, you know, k is a value. And what you're going to do is you're going to factor the binomial x minus k out of the numerator and the denominator of f of x. Now, let me clarify what that means, okay? So let's say that we have, I'm going to use a different color here. Let's say that we have the limit, like the one we just did a minute ago, as x approaches 7 of x squared minus 49 over x minus 7, right? In this particular case, k is equal to 7. So what you're trying to factor out of the numerator and the denominator is x minus 7. So you're looking to factor x minus 7 out of the numerator and the denominator. Now, there's good news in this particular problem. X minus 7 is already a factor that's by itself in the denominator, so we only have to factor x minus 7 out of the numerator, which is very easy because this now becomes x plus 7 times x minus 7 because it's a difference of squares, right? And so, to factor x minus k out of the numerator and the denominator of f of x basically means just to factor x minus and whatever your x approaching number is right there. You're looking to factor that binomial out. Here's why you want to factor that binomial out. That is the binomial, that is the factor that is causing you to get a 0 in the numerator and a 0 in the denominator. The reason you're getting 0 over 0 is because you have a common factor in the numerator and denominator that has to be canceled out. And so step 2 is just to simply factor the numerator, factor the denominator, so that you can get that factor that's causing the 0 by itself. And then in step 3, that's when we're going to cancel it out. Okay. Now you have 2 choices. Well, you have many choices, but I'm going to describe to you 2 ways of factoring x minus k out of the numerator and the denominator. One way is to just use regular factoring. So A is use normal factoring. So let's say that this is our numerator and our denominator. Okay. Well, all you have to do is use quadratic factoring, right? In this case, product sum factoring. What 2 numbers multiply to 10 but add up to 7? Positive 2 and positive 5. So this becomes x plus 2 and x plus 5. All right, I factored the numerator. Denominator factors into, let's see, we've got 2 numbers that multiply to negative 45 but add up to negative 4. I'm going to go with 45 is usually like a 5 and a 9, right? But one of them has to be negative. So I'm going to say that the 9 is negative. So I'm going to do negative 9 and positive 5. Negative 9 times positive 5 is negative 45. Negative 9 plus positive 5 is negative 4. So it's x plus 5 and x minus 9. And that's just regular factoring that you probably learned in 9th or 10th grade or in college algebra or something like that. So one way that you can factor the numerator and the denominator is just by using normal factoring. And that's usually only possible if it's a very simple expression to factor. But if it's a lot more complicated, you have another option for factoring. All right, your other option is to use synthetic division. Remember what I said in the review segment just a little while ago, that I said that synthetic division, really one of the reasons that you can use synthetic division is for factoring, okay? Now you can only use synthetic division for factoring if you know what you're factoring out. It has to be a first power polynomial and it has to be a binomial, right? If you know what you're factoring out, then you can use synthetic division for factoring. And since what we're factoring out is a first power binomial, we know we're factoring out x minus k. So look at this crazy looking thing. You don't want to factor that thing using regular factoring, right? I mean, you may have cool techniques for factoring, but synthetic division itself is a cool technique for factoring. But this is a crazy numerator and a crazy denominator, right? Okay. Now you could use a calculator with an algebraic or with a computer algebra system to factor it for you. That's fine too. But I know that if I'm approaching 3, if I know that I plug 3 in and I get 0 over 0, which you will on this, if you want to pause it and look, you'll get 0 over 0. I know that I'm trying to factor out x minus 3, right? In your mind, you can just pretend, turn that, just get rid of that arrow right there, and you got x minus 3. Now, if it was a negative 3, it would be x minus negative 3, which you have to make x plus 3, right? So I'm trying to factor out x minus 3. So what that means is I can just do synthetic division on this and factor out my x minus 3. So we're going to do that real quick. We're not going to do both of them. We're just going to do the numerator to give you an example. If you want to do the denominator on your own, that's fine. So I know that this number, the actual number that you're approaching, 3, is what goes in the half box, okay? And so to divide out x minus 3, you have to have a positive 3 in the half box. And I'm going to take my 4 and my negative 15 here. Remember, we reviewed this just a little while ago, and an 8 and a 3. I'm going to draw a line, put a 0 here. 4 plus 0 is 4. 4 times 3 is 12. 12 and negative 15 is negative 3. Negative 3 times 3 is negative 9. Plus 8 is negative 1. Negative 1 times 3 is negative 3. Sure enough, I get a remainder of 0. Got to get a remainder of 0. If you didn't get a remainder of 0, then x minus 3 is not a factor or you did something wrong. So now, what's left over here? I have 4x squared minus 3x minus 1. Well, that is what goes along with the x minus 3. And so now this becomes my numerator. I have factored out x minus 3, and over here I can do the limit as x approaches 3 of, and in the numerator I can put x minus 3 times 4x squared minus 3x minus 1, and then I can do the same thing in the denominator. And once I do the same thing in the denominator, I will then have factored out x minus 3 from the numerator and the denominator, okay? Now we're going to move on to step 3. After we have factored the numerator and the denominator, what do we do next? All right, step 3, very simple. Cancel the x minus k in the numerator and the denominator. So let's say that we have this limit here. What is the limit as x approaches negative 5 of x squared plus 7x plus 10 over x squared minus 4x minus 45? Now, you'll notice that when we were just talking about factoring in step 2, we factored this, right? Okay? And it became x plus 2 and x plus 5, and then x plus 5 and x minus 9. So what this really is the limit as x approaches negative 5 of x plus 2 times x plus 5 over x plus 5 times x minus 9. This x plus 5 is what is causing the limit to be 0 over 0. It is causing the numerator to equal 0, and it is causing the denominator to equal 0. So if we get rid of the thing that is causing the numerator to equal 0 and the denominator to equal 0, then it's possible that the numerator will no longer equal 0, denominator will no longer equal 0, and we now will be able to get closer to a number solution, okay? So, step 3, cancel the x. In this case, it's not x minus k, or it's not x minus something, so it would be x minus, and in this case, k is negative 5, right? And negative 5 means plus 5, so what we're really canceling is x plus 5. Well, there's an x plus 5 and there's an x plus 5. Cancel those out. Once those are gone, we now can move towards a solution. Now, you may still have something in the numerator and the denominator that's the same thing, but if it's not x minus k, you don't have to cancel it, okay? You may have, I mean, you still could cancel it, but you don't have to cancel it, okay? So once we have canceled that, what we now have is the limit as x approaches negative 5 of x plus 2 over x minus 9, and we can now move on to step 4. All right, now step 4, very simply, repeat step 1. Step 4 is go back to step 1 and do step 1, step 2, step 3 all over again until you get an answer in step 1. So step 1 basically just said, remember, just plug in k in for x. So after we canceled the x plus 5s, we now have x plus 2 over x minus 9. So if we go back to step 1 says to solve this, just plug the negative 5 in for x. Well, if we put this negative 5 here, negative 5 plus 2, that's negative 3, right? And then plug it in here, negative 5 minus 9, that's negative 14. And now the negatives cancel, right? So the answer to this limit is 3 over 14, okay? And now, there are some situations where you go back and repeat step 1 and you get 0 over 0 again. Well, then you have to do steps 2 and 3 all over again. And then step 4 to go back to step 1. Or sometimes when you repeat step 1, you'll get not 0 over 0, which indicates that all along there was a vertical asymptote there, okay? But usually what will happen is when you go back and repeat step 1, you'll plug your number into the function and you'll get an actual number, which is situation A, from step 1, which is that's your answer, okay? And so, step 1, plug in. If you get 0 over 0, in step 2, you're going to factor the numerator and denominator. In step 3, you're going to cancel x minus k in the numerator and denominator. And then in step 4, you're going to go back to step 1, plug your number in, and see if you get an answer. And if you do, you are done with that limit, and you can move on to the next question, okay? All right, let's do a few examples now. So we got the limit as x approaches negative 3 of x squared minus 5 over x plus 10. So step 1 says just plug in negative 3. This is our k value right here, negative 3. Just plug negative 3 in for x in all the places there's an x. So we'll have negative 3 squared minus 5 up top and negative 3 plus 10 on the bottom. Negative 3 squared, that's 9. 9 minus 5. Is 4, and so we'll have 4 up top over negative 3 plus 10, that's positive 7, so it's just 4 over 7. That is the answer. We're done. Moving on to the next one. All right, let's try this one. Maybe you want to pause it and try it for yourself. All right, so step 1 is we plug in our k value in for x in each place. So here we'll have 8 minus 4, okay, 8 minus 4, okay, which is equal to 4. Right? And then down here we'll have 64 minus 8 squared. All right, so 8 squared, that's 64, and 64 minus 64, that's 0. So what we're coming up with here is we actually wind up having 4 over 0. Now 4 over 0 is an undefined answer, okay? And what we said is that it indicates a vertical asymptote, and therefore the answer is either infinity, negative infinity, or the generic answer, which is no limit or does not exist. So we're just going to say no limit, or we're going to say DNE, does not exist. You only have to do one of those. You don't have to do both of them. Just you would either enter no limit or you'd enter DNE, okay? All right, let's try another one. All right, here's another one. If you want to maybe pause and see if you can try it yourself. Okay, so first thing we're going to do is we're going to plug our value for k in for x here and here. So we'll have 5 squared minus 25, and down here we'll have 5 minus 5. I can see already something's up here. 5 squared is 25. 25 minus 25, that's 0. 5 minus 5, that's 0. So I've got a 0 over 0. Now I need to go on to step 2, which is to factor the numerator and the denominator. Now, the denominator is already factored, right? It's just one binomial, x minus 5, right? But the numerator needs to be factored. So now what this becomes is the limit as x approaches 5 of, this is a difference of squares, it factors into x plus 5 times x minus 5. So I'll have x plus 5 times x minus 5 over x minus 5 is equal to. Step 3 now says to cancel the, here's k, so x minus k would be x minus 5. So I got to cancel the x minus 5 here and the x minus 5 here. Cancel, cancel. And what that leaves me with is just x plus 5. So now I'm going to go back to step 1, because step 4 says repeat step 1. Going back to step 1, step 1 says to plug my k value in for x. So now all I'm doing is 5 plus 5, which is 10. And therefore the answer to this limit is 10. Okay, I'd like to do another one that's like this, but a little bit harder. All right, let's try this one. You may, if you want to, you can pause this and try it on your own. First thing we're going to do is we're going to take our k value, which is -1, and we're going to plug it in for x here, here, and here. So -1 squared, that's 1, and 1 minus 1 is 0. Okay, down here, -1 squared is 1, and then 8 times -1, that's going to be -8, and then plus 7. So -1 squared is 1. 1 minus 8 is -7, plus 7 is 0. So once again, we have 0 over 0. So moving on to step 2, we now need to factor the numerator and the denominator. Okay. One way you can do this is sometimes what I'll do is I'll just use a different color, or I'll just basically do the factoring over the top and under the bottom. So x squared minus 1, that's a difference of squares. It factors into x plus 1 times x minus 1. Now what x minus k are we looking to cancel here? X minus k would be x minus -1. So x minus -1 is, and that would be in parentheses, is minus -1 means plus 1. So we're trying to cancel x plus 1 here, okay? So as you can see, there is an x plus 1 in this one. Now we want to see if there's an x plus 1 in this one. And there should be, because we came up with 0 over 0. So there needs to be an x plus 1 in there. Well, what two numbers, if we factor this, what two numbers multiply to get 7, but add up to get 8? Well, how about 7 and 1? 7 times 1 is 7. 7 plus 1 is 8. So this is going to factor into x plus 7 times x plus 1. And sure enough, we have our x minus k, x plus 1 here, here, and here. So in step 3, we cancel x plus 1. And what we now have left is x minus 1 over x plus 7. So now all we have to do is plug our -1 in here and in here. -1 minus 1 is -2 over -1 plus 7 is 6. And so it's -2 over 6, which reduces to -1/5. third. And so the answer to this limit problem is negative 1/3. I think we should do one more example that includes synthetic division. All right, so now look at this one. This one looks a little crazy. The denominator looks kind of tame, but the numerator is a little crazy there, right? Okay. Now, I'm telling you straight up in advance that we're going to come up with 0/0 on this one, okay? But when you first approach this, you don't know that. And so, in this particular case, you may want to have a calculator handy to plug 4 into the numerator there, okay? So we're going to need to do here 4 to the third power. So we're going to do 4 to the third power minus 9 times 4 squared. 9 times 4 squared. Plus 34 times 4, plus 34 times 4, and then minus 56, right? Okay, and in case you want to see how I entered that in, all right, there we go. I don't know if that helps you or not, okay, but when I press enter, sure enough, I get 0, okay? So I've got 0 up top, and now when I put the 4 in down here, 5 times 4 is 20, 20 minus 20 is 0. And so this definitely gives me 0/0. But remember, 0/0 is not an answer, so we're not going to put 0/0 over here. Okay, we're definitely not going to put 1. Okay, because 1 also is not the answer to this. Well, actually, 1 might be the answer. To be honest with you, 1 might be the answer, but it's not going to be 1 because 0 divided by 0 is 1 because it's not. Okay. So what we need to do now is we need to go to step 2. We need to factor the numerator and the denominator. Now, the denominator is easy to factor. You may not recognize it. You might say, well, that doesn't look factorable. It doesn't have a square on it or anything. Yeah, but look at the denominator. It's got a greatest common factor here. We can factor out a 5. We can factor a 5 out from the 5x and a 5 out from the 20. Okay, so if we factor out a 5, 5x divided by 5 is x, negative 20 divided by 5 is negative 4, and there's our x minus 4. There's our x minus k, right? Okay, since 4 is k, it's x minus 4. So we know we're going to try and cancel that x minus 4. That is what's causing the denominator to equal 0, because when we put a 4 in, 4 minus 4 is 0, and 0 times 5 is 0. But now for the numerator, this one's a little crazy, so we're going to use synthetic division for that, okay? Now, you might say, well, Mr. Ryan, I can't remember what to put in the half box for synthetic division. Well, let me remind you, that number right there, that k is what you put in the half box. Whatever the k value is, that's what you put in the half box. So we're going to put 4 there. Then we're going to put, what's the coefficient of x cubed here? There's a 1 there, right? So we're going to put a 1 there. Then we have negative 9 as the coefficient of x squared. Then we have 34 as the coefficient of x. And then we have negative 56, okay? We'll draw our line here. Put our 0 here. 1 plus 0 is 1. 4 times 1 is 4. 4 plus negative 9 is negative 5. Negative 5 times 4 is negative 20. Plus 34 is 14. 14 times 4, that's 56. And 56 plus negative 56 is 0. So we have a remainder of 0, which we should. That indicates a remainder of 0 indicates that by the factor theorem, x minus this number is one of the factors of the polynomial. Okay. All right. So this down here is what really matters now. This 1, negative 5, and 14. We got to reduce the power by 1. So this was x cubed. This becomes x squared. So it's 1x squared, or just x squared, minus 5x plus 14. This is what's going to go in parentheses as one of the factors. The other factor is x minus 4. And so this is what goes in the numerator. So this numerator factors into x minus 4 times x squared minus 5x plus 14. What I'm telling you is this, is that this is this factored. Okay? All right, so now, step 3, we can cancel the x minus 4 in the numerator and the denominator. And now what we basically have left, erase this stuff. What we basically now have left is the limit as x approaches 4 of the numerator is x squared minus 5x plus 14 over 5. And now we can go back to step 1 and plug 4 in for x. Okay, so 4 squared minus 5 times 4 plus 14. And we know it's not going to be 0 over 0 because we have a 5 in the bottom here. We're not plugging in a 4 in anywhere down here. It's just over 5. 4 squared, that's 16. 5 times 4, that's 20. So 16 minus 20 is negative 4. Plus 14 is 10. And so we've got 10 in the numerator, 5 in the denominator, and 10 divided by 5 is 2. And therefore, the answer to this limit is 2.